What's up, you freaking geniuses? So in this video, I'm going to teach you how to solve rational equations, all right? So you can basically break these down into 3 steps, all right? So first of all, you want to factor the denominators if that's possible, all right? Second step would be finding the LCD, which is the least common denominator or the lowest common denominator, all right? And then once you find that, you're going to multiply every single term or every single fraction by your LCD, okay? And then once you do that, some math and magic happens because then you're able to cancel a bunch of crap out and then it just turns into like a normal straight linear equation that's going to be a lot easier to solve, right? So let's start with this one right here. All right, so again, the first thing you want to do is factor the denominators. And in this case, we totally can do that. Okay, so first of all, let's factor this one over here. So if we factor the denominator over here, we can pull a 2 out from both of these, right? So we can pull out a 2. And then inside the parentheses, we're just going to be left with x minus 1, okay? And then we're going to subtract that, right, from this one right here. So we got a 2 on top. And this one, again, we can factor it, right? We can pull a 3 out of both of these. So let's pull out a 3. And then we're going to be left with x plus 1, okay? And then that's going to be equal to, okay, that's the numerator. Now the denominator, we can also factor this. Okay, so first of all, let's just bring that 12 down. The part that we can factor is this right here, the x squared minus 1, okay? Because again, this is a difference of squares, okay? So to factor this, again, all you have to do is take the square root of each of these, right? So the square root of x squared is x, and the square root of 1 is just 1, right? So to factor x squared minus 1, this whole thing right here, it would just be x plus 1 times x minus 1. Okay, cool. So we just factored all the denominators. So we're done with that. So let's move on to step number 2, finding the LCD. All right, so let's do that. Okay, so first of all, we have numbers here, right? We have a 2, a 3, and a 12. Okay, so what's the LCD between 2, 3, and 12? Well, that would just be 12, right? 12, 3, and 2, all of those fit evenly into 12, right? That's the smallest number that they all fit into. And now we can move on to the expressions, right? So we have x minus 1, x plus 1, and the same thing over here, x minus 1 and x plus 1, right? So since we have multiple, so first of all, we have an x plus 1 and an x plus 1. We're only going to write it down once, right? Even though we have more than one, just write it down once. And same thing over here, we have an x minus 1 and an x minus 1. But again, just write it down one time. Okay, so then our LCD is equal to 12 times x plus 1 times x minus 1, right? So we just found our LCD, right? So now we're going to multiply all the numerators by this LCD right here. Okay, now again, math and magic, right? We get to simplify some things. So first of all, we have a 12 on top and a 2 on the bottom. So this 12 over 2 can reduce down to 6 over 1, right? And then the other thing we can do here is cancel out, there's an x minus 1 on top and an x minus 1 on the bottom, okay? So then all we're left with on top is x times 6, which we can write as 6x, right? So 6x times x plus 1, right? So we have 6x times x plus 1. Now we're going to subtract that. So 12 over 3, we can reduce that down to 4 over 1, right? So then on top, we're left with 2 times 4, which is 8. So let's write that down, 8. And then the other thing we can do is cancel out this x plus 1 and x plus 1 on the bottom. So then we're just left with this x minus 1, right? So then we're going to multiply by x minus 1. And then that's going to be equal to, well, here, there's a lot of stuff we can cancel out, right? We have a 12 on top, 12 on the bottom. We have an x plus 1 on top, x plus 1 on the bottom. X minus 1 on top, x minus 1 on the bottom, all right? So this whole thing cancels out the whole denominator, so we're just left with this thing in the numerator, right? 5x squared minus 2x plus 9. Okay, so as you can see, now we're just left with a straight linear equation, right? So now we can start simplifying this stuff. So first of all, let's simplify this by distributing it. So here we have 6x, right? So 6x times x, that's equal to 6x squared, and then 6x times 1 is just 6x, right? And then here we have negative 8 times x, so that's equal to negative 8x. And then negative 8 times negative 1 is equal to positive 8, right? So plus 8. And then again, that's equal to this whole thing right here, 5x squared minus 2x plus 9. Okay, and I'm going to scroll down a little bit so we can have some room. Okay, now we can simplify this side a little bit one more time, right? Because we'll have 6x squared, and then we can combine these two right here, right? Like terms. So positive 6x minus 8x is equal to negative 2x, right? So we have minus 2x, and then this plus 8. And then that's equal to, again, that whole thing right there, 5x squared minus 2x plus 9. All right. So again, let's try and combine like terms so we can start simplifying some stuff. So first of all, we have a 5x squared here, so let's subtract 5x squared from both sides, since I also have one here. All right, and these cancel out. So then here, 6x squared minus 5x squared is just 1x squared, or in other words, just x squared, right? And then here we have negative 2x, so let's move it over to the other side again. So add 2x on this side and add 2x on this side. So negative 2x plus 2x, those just cancel out. And we actually have the same thing over here, right? Negative 2x plus 2x, so those cancel out also. So that was nice. Okay, and then the last thing we want to do, again, just trying to combine like terms, we can move this 9 over, right? So subtract 9 from here, subtract 9 from here. So here, these 9s cancel out, and then here we have 8 minus 9, which is just equal to negative 1, right? So minus 1. Okay, so this whole thing just equals 0, right? So then we have that equal sign still there. So we have x squared minus 1 is equal to 0. Okay, now in order to solve, let's write it up here. For this equation right here, x squared minus 1 is equal to 0. All we have to do is factor this, okay? And again, it's a difference of squares, okay? So all you have to do is take the square root of each of these. So the square root of x squared is just x. Square root of 1 is just 1, okay? So then when we factor that, we're going to have x plus 1 times x minus 1. And again, that's equal to 0, right? So that's equal to 0. Okay, so then solving for our x's right here, in this set of parentheses, x is equal to negative 1. And in this set, x is equal to positive 1. Okay, so then these are our two answers, right? So then the last thing, again, is just plugging it into your denominators and making sure none of them equal 0. Okay, so if we check this one first, x is equal to negative 1. So plugging it into our denominators right here. So if we plug in a negative 1 right here, 2 times negative 1, that's equal to negative 2, right? So then we'll have negative 2 minus 2, which is equal to negative 4. Okay, so did that make our denominator equal 0? No, so that's fine. But we also have to check it in the other denominators too, right? So let's check it in this one right here. So if we plug in a negative 1 in this x right here, we'll have 3 times negative 1, which is equal to negative 3, right? So negative 3 plus 3 is equal to 0. Okay, so since we got a 0 in the denominator now, that means this solution right here, x is equal to negative 1, is an extraneous solution, okay? So it's essentially not a solution. It's an extraneous solution, okay? Because when we plugged in negative 1 into this denominator right here, it made the whole thing equal 0. And again, you can't have a 0 in the denominator, right? So x is equal to negative 1 is an extraneous solution, right? Now let's check our other solution right here, x is equal to 1. Okay, so again, just plugging it into our denominators right here. Here, if we plug in a 1 for x right there, well, 2 times 1, that's just equal to 2, right? So then in this denominator right here, we're going to have 2 minus 2, which is equal to 0, right? So when we plug in a positive 1 into this denominator right here, it makes our whole denominator equal 0. Okay, so therefore, x equals 1 is also an extraneous solution. So this one also is essentially not a solution. Okay, so that means that this big ugly equation up here has no solutions. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below. Also, there's a couple playlists attached that I think you'll find helpful, so definitely check those out, and I'll see you there.